So in this exercise, we have to state the condition for the steady state. Before stating the condition for the steady state, we have to recall the capital accumulation equation, which is the green equation that is displayed on the screen. The capital accumulation equation says that, okay, the next period's capital stock, KT plus 1, is equal to initial period's capital stock plus investments, which equals savings. Why? Because we are in a closed economy. Remember, in a closed economy, savings equals investments. And minus the depreciation of the initial period's capital stock. The sum of these will give you the next period's capital stock. In steady state, we have a constant capital stock. And that means that KT plus 1 must also be equal to KT. In other words, we just choose to drop all the subscripts in our capital accumulation equation because everything remains constant. So imposing this steady state condition, we get that K is equal to K minus delta K plus savings investments, that is the savings rate, which is between 0 and 1 times the output. So in steady state, we have that delta K must be equal to the savings rate times the output. Of course, K drops out with K. K enters positively on both the left and right hand side. So this here is the steady state condition. And if we want the steady state condition in per worker terms, what do? If we want our steady state condition in per worker terms, we simply divide by the population size or the number of workers. So in this exercise, we assume that the population size is also equal to the number of workers. In other words, we do not assume any unemployment. So the steady state condition in per worker terms would be delta K over N is equal to the savings rate times Y over N.